Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, question 7, 2020 paper 2. A vertical mobile phone mast, DC, of height H is secured with two cables, AC and BC. The angle of elevation to the top of the mast from A, so an angle of elevation is you looking up. It's like you started here and you've looked up, you've risen your eyes up that much. So the angle of elevation from A is 30 and the angle of elevation from B is 45. Explain why the angle BCA is 105, okay? So when you're trying to figure out where they're talking about here, it's always the letter in the middle. So BCA. So it's what's called the included angle between those two lines, okay? Or you'll know it as the letter in the middle, okay? And they're wondering, why is this particular angle up here at 105 degrees? Okay, well, that's a theorem on your course. Angles in a triangle add up to 180 degrees, okay? So I've drawn the triangle there, ABC, okay? And I would say angles in a triangle equal to 180 degrees. Okay, so that's the theorem. Then do the maths. 30 degrees plus 45 degrees, 40, 50, 60, 75 degrees. And 180 degrees minus that 75 means that the last angle in that triangle must be 105 degrees. Okay, so that's how I would do A part 1 there, or something to that effect. It doesn't have to be the exact wording I have there, but they're testing, do you know your theorem? And then show the maths. Okay, part 2. The horizontal distance from A to B is 100 meters. Use the triangle ABC to find the length of Y. Give your answer correct to one decimal place. The horizontal length from A to B, okay? So is 100 meters from A to B. Okay. Use the triangle ABC to find the length of Y. Okay. Okay, so a little bit about what they've said here. So they've said to use the triangle ABC, okay, which is a non-right angled triangle. Okay, we've no right angles. We have a 30 degrees, a 105 and a 45. So no right angle in that, okay? Can you see also that that side Y belongs to the triangle BCD, okay? And that does have a right angle in it, okay? But they're not allowing us, by specifically saying use the triangle ABC, they're not allowing us to use this triangle here to solve it. Now, we don't really have enough information, but we're not allowed to use it anyway. Okay, so we have to do some non-right angled trig. Okay, so let's go to our log tables, page 16, I think. Yeah. And let's have a look at this page. So down the bottom, we've right angled trig. Okay, sine, cos, tan, Pythagoras Theorem, all stuff you're familiar with. They can only be used in a right angled triangle. They cannot be used if the triangle is not right angled. Okay, if you have a non-right angled triangle, you're on the top half of this page. So area is area. Your two rules is sine rule and cosine rule. Okay, so they are the two tools that you need to use one of to solve something about non-right angled triangles. Okay, so then the next question is, well, which one do you use and how do you use them? Both actually give you the same answer. So if you had enough information, you could use either of these. Okay, they will give you the same answer. But it comes down to how much information do you have about that triangle and which one could you use. So let me start with the cosine rule. Do you see the way it's all small letters? So little a, little b, little c, little b, little c, and then just one capital letter at the end, okay? That's important because the log tables in there, when they're explaining the formula, they use small letters for the sides and big letters for the angles. So I would say cosine rule is mainly about sides. So if you have information mainly about sides and you just need one angle, then you're going to more than likely end up using the cosine rule. The sine rule then, on the other hand, is an even split between sides on the top, angles on the bottom. Okay, or of course you could write that one the other way around. Okay, you can flip everything. Okay, that's perfectly fine. Okay, but either way, you have sides on one side and angles on the other. So it's an even split between angles and sides. And in the sine rule, you tend to use just 2 bits at one time, not 3. But so even sides and angles. Okay, so there are 2 rules. So what do we have? Well, we have a side. We need to find a side. We have an angle, an angle, an angle. Okay, so I cannot use the cosine rule, and I'll tell you why. I don't have this side. So the cosine rule uses all 3 sides, A, B, and C. Okay, so if I need to find this side y, I'd need to know the other 2 sides. Okay, and I'd need an angle, but I'm okay for angles, but not for side. So I don't have enough information to use the cosine rule. Okay, so therefore I'm down to the sine rule. Okay, so sine rule then, I'm just going to write it down here. A over sine A is equal to B over sine B. Okay, so let me show you how to use that. Well, I have to find, I'm going to clear off the green out of the triangle if that's okay, so I can use other colors. I have to find the side y, okay? So therefore, sine rule is all about sides and the angles across from them, okay? So the pair in question here is y, and the angle across from it 30 degrees. Okay, so it's why you will always see me doing something like this for the sine rule, because that's the pair that I'm going to take. It's all about pairs. Okay, can you see side A is across from angle A, side C is across from angle E, side B is across from angle B. So to make a triangle, there's an inherent relationship between the size of angles and the side of the sides across from them, okay? They are related. So that's why they work in pairs. So that's one pair for my sine rule, and I need another pair. So I need another side with an angle. Well, I don't know x, so there's no point in taking that side, but I do have this angle here and the side across from it. Okay, so how do I fill it in? Well, it doesn't matter which side is A or B or C, okay? Just as long as I take the pairs together. So let's go 100 meters over sine 105 degrees, because up here is 105, is equal to y over sine 30 degrees. Okay, so to explain, A over sine A is equal to B over sine of B. Okay, that's where I got these 4 bits. Okay, and then I cross multiply. Okay, and to cross multiply just means follow the path. So 100 sine 30. And the reason we do this is because then we end up with no fractions. So 100 sine 30 degrees is equal to, follow this one, y sine 105 degrees, okay? And I could, of course, write sine 30 by 100 here. That's okay, doesn't matter. I want to solve for y. So let's divide both sides by sine 105 degrees, because that's just a number, whatever it is. And enter my calculator. So let's hit the fraction button and go 100 sine 30, close your bracket, over sine 105, close your bracket. Ooh, and I got a lovely third. So I'm getting 51.7638 into 1 decimal place. 51, well, the 6 is going to round the 7 up to an 8. So I'm getting 51.8 for y. Okay, so I hope that's okay. There's loads of questions on the exam papers on the sine rule and the cosine rule, so if you want me to do any other one, give me a shout. Part 3, use your answer to part A2, so that's just what we're after doing, or otherwise find the value of h and the value of x. Okay, so the value of h and the value of x. Okay. Again, I'm going to clear off the triangle so we can get a look. Okay, and I'm going to bring it onto the other page so we have the diagram beside us. Okay, and let's fill in what we know. He was 100, he was 105 degrees up there, and he was 51.8. Okay, so it says use your answer to part A, part 2, which is the 51.8, or otherwise, so I can do it any other way, to find the value of h and the value of x. Okay, so the value of h, well, to find the value of h, I can't use triangle ABC, okay? Because can you see that's not a line or a side in triangle ABC. So I don't get to use that big triangle for h. So I have to use either this right angle triangle, because that has h in it, or of course, I could use this one, okay? But I have more information about this side in that I already know that side y. So what I always do is redraw the triangle just that I need, okay? So into that, I put the 45 degrees that I have here. And I know he's 51.8, and I know he's h, okay? And I'm just after noticing these two ticks here. I don't know if you saw them before. They actually mean that that side is the same length as this side, okay? Which means, let me put in the ticks. I'm trying to think if that's useful or not. It means this is an isosceles triangle here, okay? He's 90 degrees. So if these two sides are the same, then the angles across from them are also the same. So it actually means that I know that this angle here is 45 degrees. Okay, it didn't matter if you didn't see that because I don't think we're even going to use it. But they're just to explain what those ticks mean on the diagram. Okay, so right angled trig. So we're at the bottom of the log tables now. So we're sine, cos, or tan, or we're Pythagoras Theorem. Pythagoras Theorem, you'll see, is all small letters again, so it's all about the sides. If I come back here, I only know one side, I know an angle, okay? So I'm not going to be using Pythagoras Theorem here. I'm going to have to use sine, cos, or tan. Okay, so let's do that. So my rhyme, and it doesn't matter what your rhyme is, so silly old Harry caught a herring trawling off America is one, or oh hell, another hour of algebra, and you just have to copy down from the log table sine, cos, tan. Okay, so let's label my sides then. So the side opposite your right angle is always called your hypotenuse. The side opposite the angle is called opposite, and he's called adjacent. Okay, I need to find the opposite side. I need to find h, and I have hypotenuse. Again, sine, cos, and tan will give you the same answer for the angle. Okay, it's which one do you have enough information to use. It's more that than which is the right one to use. Okay, there's no right and wrong one. They all give you the same. They just take different pairs of sides. It's which one do you have enough information to use. I don't have any information about the adjacent, so anyone here with a in it is not really any good to me. Okay, I need the one that's opposite with hypotenuse, so it's going to be the sine one up here. Okay, so how do I use that? Well, I say sine of the angle equals opposite, which is your h, over your hypotenuse, which is 51.8. Okay, bring him up here so that your 51.8 sine 45 degrees equals that h. Okay, so let's put that into our calculator. 51.8 multiplied by sine 45, and I'm getting 36.628 for that. And again, to one decimal place, 36.6. Do we have units for any of this thing? Meters, they're all meters. Okay, go back and put a meters there. Okay, so that's H. I hope that makes sense. Oh yeah, I need to find X. Nearly forgot to find X. Okay, so let's find X then. Let's change color so you can see what I'm doing. So X is over here. So again, I could use right-angled trig using this triangle because now I have this side. Okay, or of course I could use the sine rule if you prefer. Do you see I have 45 degrees and X, and I have 30 degrees and 51.8. I also have 105 and 100. So very easy to use the sine rule. I could use the cosine rule. Okay, because again, I have all three angles and all three sides. So it doesn't matter which of them you use to find X. Okay, they are all going to give you the same answer. Let me do one or two of them for you. The first one I'm going to use, only because we haven't used it so far, is I'm going to use the big triangle. Here's X, here's 51.8, here's 100, and I'm going to use the cosine rule. A squared is equal to B squared plus C squared minus 2BC, the cosine of that angle A. Okay, the only thing you have to be careful of is whatever angle you're taking here, you have to put the side across from it here. Okay, they have to match up. It doesn't matter which is B and C, but the angle has to match the side. So in other words, if I put X squared over here, because I'm trying to find it, this one, okay, then I have to take this 45 degrees. I have to take that for A. Okay, if I put 100 squared here and solve for B or C, then I have to use this angle here. Okay, I hope that's not confusing, but the angle and this side have to match. They have to be a pair. So the pair I'm using, because I want to find X, is this 45 degrees here. So X squared equals 51.8 squared plus 100 squared minus 2 times 51.8 times 100 times cos 45 degrees. Okay, sorry, it's gone off. That's all one line. Okay, and they're all just numbers, so I'm going to put them into the calculator all in one go. So 51.8 squared plus 100 squared minus 2 bracket 51.8, close your bracket, open your bracket, 100, cos 45 degrees. And I've got X squared being equal to 5357.61. Okay, of course it's X I need, not X squared. Thousands wouldn't make sense anyway. So get the square root of answer. And I'm getting X being equal to 73.1957. To one decimal place then, X is equal to 73. Well, the 9 is going to change him to a 2. So 73.2 meters is what I got for X using the cosine rule. Okay, if you'll allow me, I'm going to do it a different way. Just to show you, you have options, okay? Okay. So maybe you prefer right-angled trig, okay? So let's draw that right angle over here. Let's write in what we have. We've 30 degrees. We found H, so let's put in what our H was, 36.6. And we have to find X over here. So again, label your sides opposite the angle in the question. There's your right angle, so hypotenuse, and the other side is adjacent. Silly old Harry caught our herring trawling off America. Okay, so these are the first two jobs you do in any trig question. Okay, any right angle trig question. So I need X, hypotenuse, and I need opposite, so it's going to be a sine again. Okay, again, I know nothing about the adjacent. So I have sine of the angle equals opposite over hypotenuse. Okay, bring up the x. And then divide both sides by this. Okay, and you'll note as always when x, what you need is on the bottom, these two swap places. Okay, can you see that? So x is equal to 36.6 over sine 30. Let me hit the fraction button. 36.6 over sine 30. Forgot to close my bracket. And I got 73.2 meters. Okay, so I hope I'm sending the point home that it doesn't matter which way you do it. It's whichever way you prefer. Okay, of course you could have done it using the sine rule. And that's the final way I'm going to do it. And again, it doesn't matter which pair of sides I'm going to use. I'm going to use these ones. He was 100, he was 105 degrees. Okay, so remember the sine rule. A over the sine A is equal to B over the sine B. Okay, so these are all different ways of doing the exact same thing. So let's see what we get for here. X over sine 45 equals B 100 over sine 105 degrees. Cross multiply. So I have x sine 105 being equal to 100 sine 45. Divide across by sine 105. Hit the fraction button. 100 sine 45 over sine 105. And not surprisingly, I get 73.2 meters again. Okay, so that's my point, that they all give you the same answers. Students worry that they picked the wrong one. So there's no picking the wrong one. You just may not have enough information to do it. And you'll figure that out very quickly. For example, in the sine rule, you'll have gaps all over the place here. You won't have numbers to sub it in. And then you go, oh God, I don't have enough to do the sine rule. And you scrap that idea. Okay, if you don't have a right angle triangle, you can't use sine, cos, tan. Okay, so it's what information do I have, and that leads you to which one of these should you be using. Okay, so once students know that and they've done a question or two and seen that, they've become a little bit more comfortable with trig. Okay, so I'd encourage you to try these in a few different ways and just convince yourself that it's all okay. Part B, the two cables to secure the mast cost 25 euros per metre. The mast itself costs 580. Okay, let me see if I paste. Do I get the diagram here again? Oh, great. Okay. Okay, so the two cables. So that was the two cables, wasn't it? And the mast itself was the bit in the middle. Costs 580 per metre. VAT at 23% is then added in each case. Calculate the total cost of the cables and mast after VAT is included. Okay, so the two cables to secure the mast cost 25 euros per metre. Okay, so let's work with the cables first. So what length were these cables? X was 73.2 and Y was 51.8. So let's add these together. So 73.2 plus 51.8 is 125 meters, and it's 25 euros per meter or for every meter. Okay, so we need to multiply him by 25 because that's how many meters I have, and I have 3125 euros for the cables. The mast itself cost 580 per meter. Oh, so mast is dear. So let's go back and get the height of H to see how many meters did I have, because this thing is 580 per meter. So what was H? 36.6. Okay, so we need to multiply that by 580. So 580 multiplied by 36.6 is, Jesus, 21,228 euros. Okay. VAT is added, is then added in each case. Okay, so let's add them together and get the price before VAT. Or you could, of course, add the VAT on first and then find the total. You can do it whichever way you want. Plus 3125. So I'm getting 24,353 euros before VAT. So the odd word here helps you keep on track of what you're trying to do. So VAT at 23% is added. Okay. So 24,353 divided by 100 multiplied by 23 is how you could get 23%. 560119. And of course, I'm going to add that on then. Plus 24,353. And I've got 29,954.19 for the price of that. Okay. Part C. The mast can provide a strong signal for an area in the shape of a regular hexagon of side 8 kilometers as shown in the diagram. Find the area of the hexagon. So this is how satellite Wi-Fi would work. You'd have a tower or a mast, and it can give signal off for, I suppose, a span around it. Okay, so this mast can provide a strong signal for an area in the shape of a regular hexagon of side 8 as shown in the diagram. Find the area of the hexagon. Okay, so when we look at our log tables, we don't have a hexagon as one of our shapes for area and volume. Okay, we have, well, we know rectangle and square is length by width. We know triangle is half the base by the perpendicular height or something like that. We have a parallelogram, a trapezium, a circle. Okay, so we don't have a hexagon. So can I break this into shapes that I know? Okay, so in other words, could I, for instance, do that? Not really, it's still not a shape I know. Okay, could I break it into all sorts of triangles, seeing as there's one done there? Well, yes, that looks like the obvious way to do it. Okay, so let's try that. Let me try and draw that digitally and see how well I get on. Okay, so we've broken that up into 1, 2, 3, 4, 5, 6 triangles. Okay, and they're going to be the exact same because a hexagon literally has an axis of symmetry, loads of axes of symmetry, so it all folds on top of each other, okay, which means the triangles are all the same size. Okay, so when I see this one, this is 8, it means that all of these here are going to be 8 out to the edge. So he's going to be 8, 8, 8, 8. And of course, if the length here on the outside then is 8, it means all of these ones are 8. Okay, so these are what we call equilateral triangles. Let's draw one of them. Okay, doesn't look very equilateral, but anyway. 8, 8, 8. Okay, so if an equilateral triangle, angles still add up to 180 degrees. If the sides are all equal, then the angles are all equal. Okay, so the angles in an equilateral triangle are always 60 degrees. Okay, so how do I find the area of this triangle? Because what I'm going to do then is multiply it by 6, okay, to get the area of the hexagon. Okay, can I use half the base by the perpendicular height? Well, no, because if I take him as the base, then that's the perpendicular height. It's the one that's straight up to the top of the triangle, okay? And it doesn't matter which side I take for base. I don't have a perpendicular height. Now, you can get one. You can what's called drop a perpendicular, and on an equilateral triangle, he'll be 4 and he'll be 4. Okay, so using Pythagoras Theorem then, do you see the 8 and the 4? You can work out the length of that side. Okay, so drop a perpendicular if you wish, and then you end up creating that triangle, which is 4 and 8, and then using Pythagoras Theorem. Okay, remember the hypotenuse always has to be the side on the outside. It's always your c squared. 864 is equal to 16 plus x squared. 64 minus 16 is equal to x squared. What I'm trying to show you is that there's normally more than one way to do trig. So he's a 4√3. Okay, so now you can do half the base by the perpendicular height. Okay, it's half the base by the perpendicular height. Multiply that by 6 because I have 6 triangles. And I got 96√3. They don't want the answer as a third, they want it as a decimal. So I'm getting 166.276 or 166.28 kilometers squared. Okay, so that's one way to do it, and that's dropping a perpendicular. Okay, I'm going to show you another way of finding the area of that equilateral triangle. Okay, in case you prefer it. Okay, so again, I'm going to draw that equilateral triangle that I had with the 60 degrees. So he was 60, 8, 8, 60, and so on and so forth. Okay, and I'm going to use, let me go to page 16 again. I'm going to use this one here. Okay, half AB sine C. Now I just want to draw your attention to this one, okay? Because there's only one thing you can do wrong in general with this and not take the right angle. So this formula, if I draw half AB sine C, okay? The angle that they take for the area of a triangle using this formula is what's called the included angle. Do you see it's there between the arms of sides A and B? Okay, and that's important. You could take, for example, you could take this side and use this angle. So half AC sine B. That's perfectly fine. Do you see it's the included angle for those two sides? So you end up using all three letters. Okay, or of course you could take B and C, but you'd have to take angle A. So any of those formulas, they're all the same thing. Okay, so when I'm taking this, it doesn't really matter for me in this particular case because it's equilateral, so everything is the same. So I'm going to take half AB sine 60. Okay, so let's put him into the calculator. And I get 16√3, okay? And of course, I have to multiply that by 6 because I have 6 triangles, and I get 96√3. Decimalize him, and I get 166.3 kilometers squared as well. Okay, so again, it's your preference as to which way you go, whether you prefer right-angled trig and you can drop a perpendicular, especially if you've done a subject like drawing or something, you'll be used to dropping perpendiculars, or if you're comfortable in your half AB sine C, I think it's a lovely formula to use as long as you have an included angle and two sides. This is a grand way of doing it too. Part 2, a circle which touches all vertices, fancy word for corners, of the hexagon can show areas where the signal is weak. One of these areas is shaded in the diagram. Find this shaded area. Okay, not a shape we have a formula for. I'm sure you'd agree. Okay, so we have to get it indirectly. Okay, so what shapes do we have? Well, we have a circle. And of course, we know the area of our hexagon. It's 166.28. Okay, so let's get the area of our circle. Okay, and can you see then, if I subtract one from the other, I'm going to get all these areas out here, and then I'll just divide to get the area of one of them, because I presume they're all the same out here. Okay, so let's get the area of the circle. Okay, so you know that that's pi r squared. Do I have the radius of the circle? If you think about it, it's going to be an 8, isn't it? So it's from the center out. So they have drawn the circle around here. So the radius is also going to be 8. Okay, you can see it here. So the radius is 8. So it's going to be pi times 8 squared, which is 64 by pi, 201.0619 kilometers squared. Okay, let's get the difference. So 201.0619 minus 166.28. So I'm subtracting the area of the circle, or the area of the hexagon, from the area of the circle. So I'm going to get all these outside pieces here. So minus 166.28 from that. And I am getting 34.7819. How many of them have I? 1, 2, 3, 4, 5, 6. Divide that by 6. 5.79699 kilometers squared. So to one decimal place, 5 point, that 9 is going to make the 7 go to an 8. Okay, so quite a long question, quite a few chapters. There's area, there's financial maths, there's trig. Okay, so the long questions at the end.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.